All right, class, welcome to the last section of chapter 7. This is 7.5, using proportional relationships. Okay, so basically, this section is dealing with even more stuff that you would probably deal with art. Um, and a lot of people use this on a day to day basis, using proportional relationships. More of what you'll probably seen or have seen pretty much everywhere you look is stuff like what you see here. This is a space shuttle, obviously, and this is a picture of the actual space shuttle. Now, if I asked someone to go home and draw a picture of the space shuttle, I hope they wouldn't try and paste together or tape together uh, a ton of paper in order to try and draw a picture of the shuttle that's the same exact size as the shuttle. That would be ridiculously hard and not necessarily impossible, but probably wouldn't be the smartest thing to do, which is why people usually do scale drawings, right? And a scale drawing is a form of proportional relationship that we're basically going to talk about today. So this happens to be a scale drawing of the shuttle. Now, one thing that's missing here is a little something I'll show you right now in a second. Here's another one. Guess what you see here? Well, this is a scale drawing of looks like an old locomotive. A locomotive like a train, yes. Now, if you guys notice, there's something really neat, really special actually that I want you to focus your eyes on because this is what the lesson's about today. This thing right there. Maybe you learned about this in your history class. I don't know so much about your previous math classes, but definitely maybe in geography while you're studying like maps and stuff in your social studies class. Basically, what we're going to do is talk about scales today and different proportions and how those work. Okay? And here's your heading. Using proportional relationships. Okay? So at the very top, again, as you go, pause it, write it down, and then go as you go. Okay, you obviously have notes that are pre-made for you for this lesson, so fill in the blanks as you go. Some of the pictures are already there for you as well too, so you're not having to draw so much. How can proportional relationships help you find distances that cannot be measured directly? So here's the big question. How can relationships and proportions help you find stuff or distances that cannot be measured directly? Now, the big word here that I want you to know or think about, because we're going to do a ton of this in class afterwards, is indirect measurement. And basically this means is any way that you use, whether it's using a formula, whether it's using similar figures or proportions, any way that you use to measure an object. And one thing that comes to mind that I always see people, a good example of is this right here. A surveyor. This is basically a guy that goes out and measures very long distances or heights or so forth, whatever it may be, using equipment. So he doesn't actually go out there and physically take a string or a tape measure and have one guy hold one end and go all the way across to measure the other end. He uses equipment, he uses formulas, he uses technology to help him find that stuff. So that's what indirect measurement means. It just means that you're using something to help you find a measurement. Well, what would be a good example? Well, what if I asked you to find the height of a pole, or the height of a tree, or the height of a building? How would you do it? Now, remember, you don't have to write this little helpful hint here. I just want you to know, whenever we're dealing with these type of problems, if they give you a measurement in both feet and inches, I need you to make sure that everything is converted to inches first, or all to feet. I would say everything to inches. For example, if they tell you that something is 3 feet and 2 inches high, you're going to want to change that whole thing to inches. So obviously you would be going 3 times 24, right? What would that be? 72. So 72 plus 2, so this would be 74 inches. So you would want to use 74 inches, okay? Just so you know. Let me move this out of the way now. Okay, we have a picture here. What is the height of the pole? So we're trying to figure out what is the height of this pole. Now guess what you have here, obviously. You're able to measure, you may not be able to measure how tall this pole is, but you'd be able to measure maybe the shadow that this pole makes. And you'd be able to measure how tall you are. And you'd also be able to measure your shadow. I did this with a couple students way back in the past, I think last year actually, where we did this. And we're going to get to do some of this too. So we're going to be able to set up a proportion here. So let's go ahead and set up that proportion. Remember, I don't really think it matters much, but before I do that, let me change all these numbers to just inches, okay? Just like what I showed you right now, you should be changing all these to inches. So 5 feet 9 inches. Well, 5 feet times 12. 5 times 12 is 60 plus 9. So this part right here, I'm going to say this is 69. Okay. How about 7 feet 8 inches? Well, let's see. 7 times 12. What's that? 84 plus 8. So I have 92 right here. Okay, let me just delete all this other stuff that I don't really need. And over here, 38 feet. That's pretty long. 38 feet times 12. That's 456 plus 4. So I'm looking at 460. Okay, so there are your numbers. We're going to use all these, okay? And again, we still need to know what that h is. So let's go ahead and write a proportion. And by now, I hope you know that setting up proportions here, it doesn't really matter what order you put stuff in, as long as you have some sort of order. So I could say that, for example, let me get my pen here. I could say 69 is proportional to h as 92 is proportional to 460, okay? Now, you could have done it the other way too. There's tons of ways to do this. You could have even done it this way. 69 over 92 is equal to something over 460. So you could have done it just like I mentioned right now. Let me actually write it right here just in case some of you want to try it this way. 69 over 92 is equal to something over 460. It'll give you the same answer, okay? Let me go ahead and do this one over here. X times 92, that's 92x equals 69 times 460. Guess what? I am super good at these. I'm getting so good at these. I could do it all in my head. 31,740. Divide by 92, divide by 92. And yes, this will take a little bit of work, obviously, on a test or on a worksheet if you're not using a calculator, right? Now I have 345 inches, okay, left over. So if I asked you guys to make this into feet and inches, then you would do 345. You would see how many times 12 goes into that. And it looks like 12 goes into 345 28 times. So again, you would write it, if you were to work this out, you would be doing long division, okay? And you would say that this goes into it 28 times. So 28 times 12 would be at 336. How many would we have left over? 9 inches. Okay, so this would be the same as 28 feet, 9 inches. Now again, we're going to practice more of this in class, preferably probably trying to find different heights outside of our classroom. So let's take a look at scale drawing. Scale drawings is probably what you've done in your art class already, or maybe even in an in a previous math class. A scale drawing says a drawing that represents an object as smaller or larger than its actual size. So I showed you a couple of examples of an object that's smaller than the actual size. The space shuttle that I showed you and the locomotive. Okay. Now the scale the ratio of any length in the drawing to the actual length. The scale of a drawing is actually usually like within the picture, like I showed you over here. Look at this train. See this part I highlighted right here? This is your scale. It even tells you right here, scale. Now, some scales are a little harder to read than others. So usually it'll say something like this. The scale, for example, here says, for every inch on my paper, that means 200 feet in real life. And that's basically all that says. Or, for example, if I had something like, for every centimeter on my paper, that means 3 miles in real life. So you're telling someone what it means. You're in charge. If you're drawing it, then you should be telling them what it means. Okay? So let's take a look at how scales can be used. And this came out of your book. Okay, so this is example 2 in your book. This says the scale of this map of downtown Dallas is 1.5 centimeters to 300 meters. So that means that if I was to take a ruler, and let me see if I could find a ruler here. So I have one, so you can see me doing this and not just kind of pretending. So I'll search for a little quick ruler here. I will pull out my imperial ruler here. Actually, that's inches. I don't want inches. I want centimeters, right? So let's see, centimeter ruler. Let's see how this works. Does that work? It's a horrible example. One more shot. Let me see. I think a metric ruler is going to work for me. I think these are centimeters here. I hope they are actually. So let's see if this actually works. Does that look about right? 1.5. Let me see if that. I'm looking right here where my scale is. Is that about 1.5? I'm going to say it is actually. That's pretty good. From there to there is 1, and from 1 to a half, well, that's 1.5. So this actually works really good for me. So here it says, find the actual distance between Union Station and the Dallas Public Library. So we're trying to find the distance from here to here. Now, if I was to take my ruler, I'm going to do this for you. What is it about? It looks to be, I'm going to say about 6, okay? So I'm going to say about 6. I'm a little off, but I'm going to say it's about 6. I can rotate a little bit better just to kind of make it look even better. Yeah, it's 6. So here's how you set these up. I'm going to write a proportion. So I know that 1.5 centimeters on a map is the same as 300 meters in real life. That's why I wrote a proportion equals, but what did I just finish measuring? Did I just finish measuring centimeters or did I just finish measuring meters? I finished measuring centimeters and I did 6 of them. So I'm trying to find out what this is right here. What is it in real life? So I'm going to put down an X, okay? And you should be doing 6 times 300 is 1800. And I'm going to divide that by 1.5. And I end up with 1200. And that 1200 is not centimeters, that 1200 is in meters, okay? And so that's your distance. Let's look at the last example that I have for you here. Now, a ton of stuff happened in Washington, D.C. This past weekend with the inaugural presidential inauguration. So a lot of landmarks out there in that area. And one of them is the Lincoln Memorial. Okay, so let's take a look at this. It says, the Lincoln Memorial in Washington, D.C. is approximately 57 meters long and 36 meters wide. Make a scale drawing of the base of the building using a scale of 1 centimeter to 15 meters. So they're telling you what the little smaller picture should look like. This is a picture of a big one, obviously, but you're trying to draw a small picture to scale. So like it says in step 1, I want you to set up a proportion. And we're going to need to find out what the real length and what the real width is in our drawing. Now our proportion is right there. They give it to us right here. Well, here's part of it. Part of it is 1 centimeter to 15 meters. Now, we're going to do this one at a time. We're first going to do this for the length for 57, and then we're going to do it for 36, which is the width. Okay, so we're going to do it twice. So we're going to do the length here first, and we're going to do the width second. So for the length, what length did they say this was? In real life, it's around 57 meters. Now, where should I be writing this down? You tell me if I did this the right way. Does it seem like I did this the right way? Look at what I have over here on the left side. Right here. I have centimeters on top and meters on the bottom. So if I'm using this, then I want to keep it that way, okay? I'm going to want to have 1 centimeter on top, meter on the bottom. So I need to fix this. So now I'm going to cross multiply. So I'm going to have about, let's say 57 divided by 15. That's going to be around 3.8 centimeters. I don't know, I got, should be just using X, right? There's your X right there. I'm sorry. I shouldn't have been using that M there. That M is kind of a little confusing. I just wrote the M and the CM so you knew where everything goes. Let's look at the last one here. We're going to use the same ratio again, but this time they say they want you to have a width. They want the width, which is 36 meters in real life. So they want to know, well, what would it be in a drawing? Okay, well, 36 meters goes on the bottom with the other one right here. Why did I write centimeters? Anyone tell me? Why don't you guys tell me, Mr. Polo, you're making mistakes here. So I have something on top, I don't know what it is, over 36. Because this is meters again. Now when I'm multiplying again, I'm not going to pay attention to the m's or the cm's, okay? I'm just going to do the math. So this is going to be 36 times 1. That's 36 equals 15 times x, 15x. Divide by 15, divide by 15. And what's 36 divided by 15? 2.4. So let me write it over here because I'm running out of room. Right on top, I'm going to write, okay? X equals 2.4. So you just found out what the width is. You just found out what the width is. I'm going to highlight the width and the 2.4. And you just found out what the length is. So those would be the real measurements in a drawing. If I asked you to draw this with a ruler, you would take a ruler and measure it, and you would get something like this, where like the length would be 3.8 centimeters, and the width would be 2.4. And that's all they really wanted you to do. They wanted you to be able to scale it down to something smaller, like it is right here, okay? And I think that's about it. That was a short lesson, but it all had to do with scales and using scales and proportions, okay? Same stuff we've been doing in the entire chapter. All it is a simple little setup, setting them up proportionally, okay? And sometimes they require you to measure something with a ruler. You learn what the definition of a scale drawing was and what scale was. And you learn how to measure something, how you can find something indirectly. Okay, like for example, again, if you didn't know what the height of a pole was, we were able to find out what it was without actually measuring how tall this pole was. We used a proportion. And that's it. The only thing is I have homework. Homework, work page 93. numbers 1 through 8. And that's it. The last thing I will show you, we'll do that in class. And I'll end it with this. How many seconds are there in a year? Go ahead, it's an easy number. You can guess. Any guesses? 12. January 2nd, February 2nd, March 2nd, April 2nd, May 2nd. There's only 12 of them. That was pretty funny. All right, guys, that's it. Thank you.